Hey guys, I'm in the laboratory and today I'm going to be showing you how to do a gravimetric analysis. I have a sample with unknown amounts of sulfate. In this video, my goal is to show you how I will convert the sulfate into a solid, barium sulfate, and weigh the barium sulfate for use in my stoichiometric calculations. I hope you're excited to learn, and let's do some experiments. The first thing I'm going to do is to accurately weigh my sample. I head over to the analytical balance to measure my sulfate solid. Here is the mass in grams. I wrote this down on my laboratory notebook. The next thing I need to do is to dissolve my sample in water and acidify it. I'm adding here 20 drops or roughly 5 milliliters of 6 molar hydrochloric acid. Acidifying the solution helps with the dissolution of this solid, as well as eliminating the possibility of solids other than barium sulfate to precipitate later on. I transfer my solution to a hot plate and heat up my solution. I'm now going to soon precipitate the sulfate as the white solid barium sulfate. Heating up the solution increases solubility, so that's gonna help me grow my crystals slowly. The slower that crystals grow, the larger they become, and hence the less likely that they will pass through my filter paper later. I'm not allowing this to boil because making the solution splatter will disrupt the crystal that I'm growing and might cause losses of sulfate outside the beaker. Once I'm at a good temperature, I'm slowly adding in barium chloride and stirring vigorously. Barium ions will react with sulfate ions in a 1:1 ratio to form insoluble barium sulfate. If I dumped all my barium chloride immediately without stirring, my solid will become a powdery mess. Again, I want to encourage a slow and steady crystal formation, so I'm taking my time. I'm adding barium chloride in unmeasured excess. I don't really care how much I'm adding as long as I'm adding enough to convert all the sulfate to barium sulfate. I'm going to let this sit or digest over the next 20 minutes so that the crystal can have time to grow. While I'm letting my crystal cook, I'm now going to weigh my crucible. Later, we would need to dry the precipitate to eliminate water and other volatile contaminants, so we will need to transfer the precipitate inside the crucible. Because the crucible itself could contain moisture, its weight will also change after heating. I've already gone ahead and heated and cooled this crucible over and over until I recorded this constant weight. After my crystal has been left for a while, the solid has settled to the bottom. I just need to check now if there are any unreacted sulfate. I do this by adding drops of barium chloride. If there were any sulfate remaining in solution, I would see clouds of precipitate forming. Luckily, there's no more solids formed. I'm now ready to retrieve my solid. I transfer to my filtration setup and slowly add the contents of my beaker. I'm using a special kind of filter paper called quantitative or ash-free filter paper. Because I need to weigh the solid, I need to remove the filter paper. But because it's ash-free, I can just burn it and all of the filter paper will be converted to gas. I'm transferring and washing all my solid with warm water, and I need to keep washing to ensure that no more excess chloride remains. I can test the presence of chloride by adding in silver nitrate, which forms silver chloride. Essentially, I need to keep washing my solid until adding silver nitrate forms nothing anymore. I'm folding my filter paper into a little pouch, and then I transfer it into my crucible. From here, I transfer my crucible to a furnace so it can heat it and burn away the filter paper. After heating, I'm transferring my crucible to cool in my desiccator, which is a special moisture-free environment. So when it's cool, I can weigh this crucible once more, and if I subtract the empty weight, I should now have the mass of barium sulfate from my sample. That was exhausting, but it's all worth it in the end. I'm now done with my gravimetric analysis. I now have enough data to calculate for the percentage of sulfate in my original sample. I hope you could see yourself doing gravimetry in the future, and I hope you're excited for what's to come. I'll be seeing you next time.